Good morning, everyone. And how are we today? Good morning. Right now, there's no two ways about it. Yesterday was a very long day, wasn't it? And many of you are dealing with clocks that are on different time zones. And it's at times like this when our thoughts tend to drift when we're tired towards our loved ones. And especially, it's the case when we have young children, isn't it? And I say this because it gives me a great excuse to share a personal story with you. Yesterday, my phone pinged at some point during the afternoon, and it was an image of a photograph my son had drawn for me. I left a set of coloring pens for him as a surprise while I'm here. And the picture just brought to life everything that we're doing here, really, which is providing the ingredients for our best life, our happy, healthy life. It was a picture of me and him walking along the hills, covered in green grass, with above us crisp, fluffy clouds, in a brilliant blue sky with a happy sun shining down upon us. And it's important, I think, that we remember that actually that is a big part of this story. It's about a happy, healthy earth that'll give us our happy, healthy life. But it also gives me another excuse to share something else. You see, the way I got him to find the coloring pens was through a poem I wrote. I bashed it out very quickly yesterday. It was full of clues. And this morning, I'm sure you'd be delighted to know that I've done the same for us. It's my first ever attempt, so please indulge me in a minute. And if it's a bit too cheesy for you, I apologize in advance. Now, our panel this morning, I think, really brings together everything that this forum is about. It's about inclusiveness, diversity of skills, outlook, opinion. The people that we're going to be hearing from in a few minutes include the scientists, the citizen scientists, and somebody who actually advocates that we shouldn't be drawing these hard lines between the arts and the sciences. And I actually fully agree with her. But it's interesting that because she's an astronaut, we tend to take what she says that bit more seriously, don't we? Now, on with the show. There's no two ways. Oh, that was the wrong one. Where is it? It's over here. Okay. There's little greater than the right kind of data to help us on our quest for planet Earth to be her best. Lest millions, nay billions, pay for what others do every single day. What we need is an alliance of all of us citizens and our science. There you have it. And now I'd like to invite to the stage the person who heads up GEO in Geneva, Barbara Ryan, alongside, on behalf of the Abu Dhabi Environment Agency, Ahmed Baharoun.
Well, good morning, everyone. My name is Barbara Ryan, and last night when the Data Visualization Award was being presented, there was reference to a Citizen Science Award, and yet there is one other award that the Ion Earth Alliance offered, and that was a blog competition. So we're going to take a little segment out of this morning's session to present the blog competition winner. The theme was a better world through knowledge and information. And the task was actually how data and information could make a difference in the lives of ordinary people. So a little bit later on when we talk about extreme science, this will be a key point. There were 106 entries from 37 countries. The winner was actually, their product was actually a fictional post about how data and knowledge could impact our lives in the future. Now, we'll have to see if it was 100 years in the future, which you'll hear a little bit later about from May. But before we actually announce the winner, let me turn it over to Ahmad for a few words.
Well, I just want to congratulate our winner for her contribution on behalf of the Eye on Earth organizing committee and the judges. Um, she did great. It was outstanding contribution that she did, and we encourage more for innovation and all the good work that she did. Thank you.
So without further ado, let's welcome to the stage Elizabeth K. Tyson from Washington. Actually read Elizabeth's blog. It's on the Eye on Earth Summit website, so it's www.eyeonearthsummit.org. So listen, again, I've got the task of introducing the panel and moderating this panel discussion. It's going to be just in my mind, an outstanding panel. So what I'd like to do is invite all the panelists to the stage right now. And then once you get up here and get seated, I'll give a couple sentences about each of you. And then I've got just a couple slides that will maybe set the context for this entire event also, because when we talk about data revolution from the supply side, there is no doubt that there's a revolution on any different fronts. Volume of data, so velocity, veracity, you know, we often talk about the five V's of this whole data revolution. And I think each one of these speakers will touch on some point of that stream. So first of all, Phil Manjara. Phil is Director General of the Department of Science and Technology in South Africa. He has also, and what's most important to us in the Group on Earth Observations is that he is one of 4 co-chairs for GEO. And I can say that Phil has been with the Group on Earth Observation since its inception, and of course its roots were in the first World Summit on Sustainable Development in Johannesburg. So Phil Manjara. Next to him is Mary Glacken. Mary is Senior Vice President of the Weather Company. She is particularly focused on public-private partnerships, so an event like this is really important to Mary and to the Weather Company. She was a senior executive for NOAA, the National Oceanic and Atmospheric Administration, for many years. She's also on the commission for the American Meteorological Society. Thank you, Mary. Next to her is Muki Hackley. He's professor of Geographic Information Science at the University College of London. And it's Muki that if you look anywhere in the program and see this reference to extreme citizen science, that's Muki. Next to him, Chris Tucker. Chris is a creator and founder of the Map Story Foundation. So I think what Chris is trying to do, and we'll hear about it more, is really do for maps and geographic information what Wikipedia has done. And there were references yesterday in the remarks about the transitional nature that Wikipedia has provided. So Chris, welcome. He's also a counselor to the American Geographical Society, and actually also on the board of directors for OGC, the Open Geospatial Consortium. Mark Reichert, the executive director for OGC, is in the audience. So welcome, Mark. Welcome, Chris. And last but not least, there have been many references to May these last couple days. Mae Jemison, she'll be here to talk about the 100-year Starship Project. And so when we talk about the blog looking out into the future, the Starship Project is really trying to assure human capability for interstellar travel to another star within a 100-year time frame. So a little bit out there. And May is the former astronaut that so many people have talked about these last couple days, so welcome, May. So, introduction, just a stellar panel. I've got just one or two slides that I guess I'd like to have put up right now to set the context. So the panel that you see right here, when we talk about just the sheer volume of data that's available now, this is just a graph of the Landsat story, a story that I have some personal experience with. But if you look at the bottom line, it's from 2008 to 2014, and these are just number of downloads of Landsat data. Now, the first Landsat satellite was launched in 1972. So 1972 is probably over here on the wall somewhere. And what you can see at the peak of data sales, when this data was being sold, 53 scenes a day. 53 scenes a day. Now, it's a substantial amount of money for $500 a scene, 365 days a year. So $4.5 or $5 million was actually coming into one federal agency. As soon as the United States used the Group on Earth observations to announce a broad open data policy, the trajectory is shown here. 2 orders of magnitude, 53 scenes a day to 5,700 scenes a day. The number now is higher. This is out until maybe 2014, the beginning of 2015, well over 25 million scenes. I think the story here is this is one country, one satellite. Think about the assets and the access to information if the entire world was downloading data at this rate. And so, but that's not the only story. When you looked at that 53 scenes a day and who was buying them, number one, other federal agencies. Number two, universities funded by federal dollars. Number three, contractors funded by the Defense Department. So for this particular asset, it was a government asset, and those $4.5 or $5 million were just changing pockets and incurring administrative costs. So it's good government for government agencies to have broad open data policies. You are only creating a barrier, number one, to your sister agencies by selling data, no matter what the revenue stream is. And it's good for the economy. An economic analysis that was done, again, on just this data set, United States, $1.7 billion economic return in 2011, $400 million elsewhere, for a global return of $2.1 billion that far exceeds the $4.5 or $5 million that one federal agency was getting for this information. What are people doing with this? Oh, Canada's experienced the same thing. They opened it up at least to other federal agencies, not to the world at large. They see a 1 order of magnitude increase, 5,000 scenes a year up to 35,000 scenes a year. So government agencies, at the very least, need to be sharing their data with other government agencies at no cost, and preferably with the public at large. What are people doing with this data? Stuart mentioned Geosciences Australia is in the audience. Geosciences Australia took that entire Landsat archive for all of Australia and put it into something called a data cube. It absolutely is revolutionizing how data analysis is going to be done, allows the comparison of big data through time, and just creates really dense time series. And so you can see just the positioning of this data, which really, all I can say is you need to talk to Stuart in Geosciences Australia. He's also the geo-principal from Australia. And so lastly, Australia is a big place. There's a lot of Landsat scenes. But you know, this is only, again, one satellite and one country's satellite. Can you imagine if all of us could really unleash the power of Earth observations and do the kind of analysis that Australia has done, in this case just looking at how water has changed in a particular basin over very, very long time periods, and then the frequency of those areas over that same time that have been wet, dry, or something in the middle. So that is my last slide to set the context. You will hear many more examples of this as we go through the panel. And so, Phil, I would now like to welcome you to the stage for your presentation. So thank you very much, everyone, and look forward to a wonderful session.
So is it loaded? Whilst the presentation is loaded, thank you very much, Barbara, and thanks very much to the organizers to ask me to come and say a few words on the work that we're doing in GEO. So the slides that I will be presenting is not my work, it's the work of the entire Group on Earth Observation community. So the way that I'd like to convey my message in the next, this is very quick, I'd like to share with you 3 case studies. The first 2 case studies are trying to convince you that the amount of data that we have to deal with keeps growing. So I'll probably remind you what's happening on the internet, and then I will also come back very quickly to what we as researchers have to deal with in terms of the evolution of data. And then later on, of course, I will share with you the third case study of how data is evolving in GEO, and in particular how not only are we worried about the data, but how we're using this data to inform decision making. So this is a slide that, again, shows how on Earth observation there's an increased demand for Earth observation data. We had this yesterday, and again, this slide just reminds us that indeed we have to constantly worry about the volume of data that we have to deal with. This second slide just reminds you that on the internet, if you started from where the internet started, if you thought what happened at the beginning of the internet was large volumes of data, 2015 and beyond, we will also have to even be more worried about the data that will go into the internet. And then the third, or maybe the second case study that I wanted to show you is a case study of the publications that were picked up by a company called Elsevier that we work with in South Africa. It collected data on the number of publications that are produced in South Africa. So I apologize that the 17,000 that we produced, which is a small number, maybe you can't see it on the screen. And then the next data source is the number of publications in 2014 that were produced in Africa. And the third one shows you the amount of data and publications that are published in the rest of the world. Now, the question is, how long would it take you if you were a researcher? And again, in the interest of time, I'm not going to read the words that you have on the slides, because Barbara said I must try and do this in exactly 12 minutes. Again, you can do your own maths in terms of how long it takes you to read a publication, and then if you multiply the number of hours that you have to put in to go through this data, you can see that as a researcher who may not be living through a lifetime, you are going to have to need a different set of tools rather than going through this data through a lifetime. And Elsevier has been looking at different way in which you can look at the search engine optimization. I mean, I remember when I was doing my own research, the volume of even the data and the publications and the review that you had to read were enormous. And they've been developing this search engine, and they're optimizing it, and it wonderfully can give you recommended articles that you're looking for. So what can we learn from this? So this is a schematic diagram on how they've been able to say, one, we have large volumes of data. Secondly, if someone has to go through this large volume of data, they need a search engine, and they've designed this search engine that allows them to make it easy for you to search and write some search words, and then it will be able to give you the kind of publications that you're looking at depending on the topic. So this is, in a sense, the moral of the story then in GEO. GEO here meaning Group on Earth Observation, where we would like to realize a future where decisions and actions for the benefit of humankind are informed by And this is the important part of GEO: coordinated, comprehensive, and sustained Earth observations, and most importantly, information. These are members of GEO. At the moment, we have about 99 members, so these are governments that are participating in GEO. And I apologize that there are two parts of the world which are not well represented. The first part is the continent that I come in, and I will talk a little bit later about how we're trying to address that problem. And then the second part is the part of the world where we're in, and therefore we are really looking forward as GEO to be looking at how we can work with this region. My sense is that only Bahrain at the moment is a member of GEO, so we look forward to continued engagement. And then the next slide, which I am not expecting you to read, is the participating organizations that participate in GEO. So you can see that this is an organization that is using its power to convene both governments together with participating organizations to do something that I think we would like to share in this slide. So we would like to improve and coordinate observation systems globally. We would like to provide access to data and information, advance broad open data policies and practices. Barbara has already talked about what happened in the US with Landsat, and most importantly, to build capacity. This is just a schematic picture of what we're trying to do, a global system of systems. So we are trying to really, truly build a global system. So on the left-hand side is a picture of the Earth with all the instruments, either satellite-based or airborne-based, that we are trying to connect in order to get a better understanding of the societal benefit areas that you see on the circle on the right-hand side. Because this is what we have done to our planet, we have increased the CO2, but it's not only that. I was, because I'm a condensed matter physicist, informed by earth science scientists that we actually don't understand how the Earth system as a system works. We do not understand the interrelationship between the land sphere with the ocean, and therefore by having a global Earth system of systems, we can begin to do the kind of science that it's never been done before. So this is how then we're organizing ourselves. We have three components of GEOS. The first component is the component at the bottom where, as you can see, we are trying to connect data from a variety of collecting infrastructure, be it aeroplanes, as I've said, be it balloons, be it satellites or buoys in the sea. And then we have an infrastructure and information system in the middle that then allows all the data to be fed from the Earth observation system in order then to provide the information that is needed by the various societal areas. You can also think of this system as a system where you have a number of system providers that come together, and they provide the information into what we call GEOS common infrastructure, which you see in the middle, and then this becomes a two-way process. The one process is where the data providers provide data into the GEOS common infrastructure, we call it GCI, but you can also begin to identify gaps in terms of Earth observation data that you need, so it's a two-way process. And then, of course, what we would like to do is to really begin to use this data to begin to get a sense of how the Earth system works and begin to provide decision makers with information that they need. And this is an iterative process. So again, these are a range of systems that are out there that we would like to connect together. And what we have done in the last maybe 2 to 3 years, I suspect, we have then been speaking to the data providers to make sure that through our open data policy, as they provide the data into the GCI, this data is brokered. So you can see that you enter the GEO website, and then you have, we have been building what is called the data accessibility and brokerage process. So in order for you to navigate through this whole data, the same as I did with the case study of researchers who have to navigate through a range of publications. So we've been able to at least attempt to do this. We are aware that this is less than ideal at the moment. This is a work in progress, and in the next 10 years, we would like to improve how this data is accessed into the, or from GEO's common infrastructure. This is again showing you how the data providers, so how the data has evolved into the GCI over the years. And then of course, if you look at the year when we introduced the brokerage, you can also see that the data that has been brokered with a number of users is also showing this exponential increase. So GEO then works across the value chain. We work with those that are providing data in order to build this global Earth observing system of systems. We then work with those that are interested in adding value to the data. And then of course, if we can find, not necessarily GEO alone, but to find those who like to use the data for decision making, have been able, can do this. Now, a breakthrough happened, I think, in 2008 when data sharing policy was, I think, announced in Cape Town. And I'm sorry, I have to use the fact that this was done in Cape Town. But over the last couple of years, we've been spending a lot of time looking at how we can develop full and open exchange of data policy. Because as you can see, all of these data providers can have the data, but unless you have a policy on how this is, data is already provided, but also access. So data and products must be provided at minimum time and delay and at a minimum cost, especially for people who are working in the public good domain. And then, of course, it's free of charge or cost of reproduction by the data providers. This you have seen from Barbara, so I will not talk about this. What I would like to remind you is that we have this quote that uncertainty is the enemy of investment. Shared information is the antidote to uncertainty. So this, we believe that in GEO, this is very, very important. I just want to quote one example where not only have we been worried about how data has evolved and how we need to be thinking about designing a common infrastructure that is intelligent, but here is work where GEO was asked by the ministers of agriculture, the G20, to say, we are sometimes worried about the price volatility of the food. And this is a diagram that shows how over time, the price volatility of certain crops have gone up. Now, the question is, can we find a way in which we can use this data together with Earth observation data, the slide that I showed before, in order to understand how to manage this volatility in food prices. So for the first time now, you're seeing Earth observation data compared with market information data. So within GEO, then, what we've been doing is we have therefore been working with these ministers to develop something which is called Agriculture Monitoring Information System. So now it's not only data, but data is being used in order to provide information. So what you see here is Earth observation data that has been collected and been provided, which shows you in different parts of the world, and the legend that you see on the left-hand side are the conditions for the various crops in various parts of the world. And therefore, you can use this information, and for instance, if you look at what happened in the rice crop in Southeast Asia, you were able to use the Earth observation data in order to get a better sense of how the yield would look like. And then in particular, if you looked at what the Thailand had to watch, you can see that the green means that we will be okay, yellow means that we had to watch, and then of course the gray meaning that we need to really watch seriously how we're going to get. So again, Earth observation combined with other sources of data providing decision making for people who are looking at this. Now we should remember that countries have borders, but Earth observation doesn't. And it is for this reason then that as the last message that I'd like to leave you with, and I did show you this slide in terms of how in Africa we are represented in GEO, we have come up with this concept which is called AfriGeo. So it's a framework within the continent that we would like to use to really coordinate the activities of Earth observation in the rest of the continent. And we've been spending some time, and this is an initiative that is led by Andiso, who's sitting in the front in GEO, to look at how we can have data access and dissemination, including capacity building in the rest of the continent. This is an initiative which we are supporting in GEO, and we believe that the fact that you do not have maybe the infrastructure that you need in the rest of the continent does not mean that you cannot do anything in the meantime. And then we've been spending a lot of time trying to find a way in which we bring countries and participating organizations and some of the partners that you see in this slide in order to make sure that Africa is not left behind. So in conclusion then, we hope that we have convinced you that data is evolving and it's growing exponentially. We are, of course, saying that should not be a worry for us. We need to be thinking about tools and algorithms to get into this data. We need to use it for decision making, and here I quoted one example. There are many, many, many others. A couple of years ago, we worked with the biodiversity community to look at GeoBond and making sure that we connect all biodiversity observation networks, and now we have regional biodiversity observational network. It's another example on the forestry. Again, we have another example. And of course, we would like to offer the experience that we're having in the AfriGeos domain, perhaps to this region, on how you can take advantage of the data that is available for decision making. Thank you very much. Barbara, I hope I can say 12 minutes.
Mary, we'll just go up. Thanks, Phil.
Good morning. It's really my pleasure to be here. I suspect I'm like many of you, and we're really humbled about the challenge that we've been brought to talk about today. And what I would like to do is actually take a perspective of looking at this challenge through what's been going on in the weather world and how we've been working to serve citizens globally with the best information that we can. So thank you, Barbara, for my introduction earlier. I spent most of my career in the federal government. I'm currently, though, working for a private company today, and I'll be speaking from that perspective. But it's a private company that's really committed to public-private partnerships. It's the Weather Company, and many of you may know it by the Weather Channel or possibly weather.com. Mobile devices. I'll talk a little bit about one of our subsidiary organizations known as Weather Underground in this presentation, and we also have a business unit known as Weather Services International. So why do I want to talk about, weather? It's something that affects us all. It's actually the way climate frequently manifests itself with extreme events. People have a hard time understanding climate and climate changes, but they tend to understand when extreme events happen. And often this is how Mother Nature really shows her energy. For example, in the last week, we had historic flooding in the southeast part of the United States. Rainfall levels that had never been seen before, lives lost as a result of that, and significant infrastructure damage. So when Mother Nature really manifests itself like that, people listen and pay attention. So as we talk about these large global challenges that we have, I think that when we have extreme weather events, it presents an opportunity for us to talk to our citizens about the environment and how it's important to observe the environment, respect the environment, take care of it in the long run. So how do we get weather? So it's about the atmosphere, and I have numbers sprinkled throughout my talk today. The 100 refers to the number of kilometers of atmosphere above us that really influence the weather. And it's our challenge to really understand what's going on. I love the quote Phil gave, and I guess attribute it back to Barbara, that countries have boundaries, but Earth observations don't. And I don't think it's anywhere more true than with respect to weather, that you really need to understand globally what's going on. But it's not just about the atmosphere. Pierre Cousteau yesterday reminded us about the ocean. And the ocean is really an important part of this. The 3.6 in this case represents just the average depth of the ocean. We're familiar with looking at globes and seeing how vast they are, but Pierre is quite correct in saying that we're really doing a very poor job in observing the ocean. And it's very clear to us in the field of meteorology that if we were doing a better job there, we could make better forecasts for that. It's really the interaction between the ocean and the atmosphere that drives so much of our weather, and we have significant challenges in that regard. So I want to kind of lay out and talk on the next few slides about the three challenges there really are in terms of keeping people safe with respect to extreme weather and helping businesses and therefore livelihoods of citizens make smarter decisions, both capitalizing on opportunities that weather provides as well as taking the steps that they need to safeguard against hazardous weather. And these challenges are about mapping the ocean and the atmosphere, forecasting the future, no big challenge there. We know how easy that is. And then I think actually the biggest challenge on this slide is actually engaging the decision maker, because this is not just a supply problem of put the right information out there. It's really engaging with decision makers so the right decisions are made. So with respect to mapping the atmosphere and the ocean, both Barbara's talk and Phil's talk really highlighted, some of the work that's going on here. And the job of mapping the oceans and the atmosphere has traditionally been one that's belonged to nations to do. You can go back into the history of nations where they observe their atmosphere and ship observations and things like that. But that field is changing very quickly, and you're seeing private companies come into this field. You're seeing universities, other organizations coming into there, and that's a good thing, I think. It's not without challenges, and I'll speak about some of the policy issues in the future sides. But I do want to talk about what I'm showing on this slide here, the picture on this slide. And it's actually a picture of locations where global citizens have chosen to make an investment to buy a weather observing system. It could be a very minimal one that just reports temperature, wind, precipitation, or it could be something more elaborate. They've chosen to buy this system and connect it to the internet and provide it to one of our subsidiaries known as Weather Underground. We refer to these citizens as weather enthusiasts. They care about weather, and in return for this investment, we provide them an up-to-date forecast of what's going on at their weather station, what's projected to go on at their weather station, but also provide them insights as to what their neighbors are doing. So I think it's a great example of citizen science. What's really interesting to me, though, is you can see the very heavy density in the United States, where we've been working at this for about 15 years. The rest of the globe, though, we've only been working at this for the last year. And every month, we're adding thousands of these sensors that are coming online. So you're starting to see this fill out in populated areas around the globe. I'm pleased to be saying we're going to be providing this data into GEO, and I think it'll give us another good perspective really from the ground in terms of what's going on. And I think how we engage these citizen scientists going forward will be very interesting as we meet the challenges that are ahead of us. There's the number for 147,000 as of the end of August. So I want to talk about this forecasting challenge that's here. I won't dwell on this too much. It's really could be, if people want to stop me offline, I'm happy to talk about this more. But again, this has been an area that's traditionally been the domain of the nations to be able to make the forecast here. And that's been because of the very complicated computer models that are involved that need very high performance computing. But things are changing as we move forward with cloud computing and other things, and you're seeing more players in this field. But to make a forecast, you really need very up-to-date information about the atmosphere, and you need it around the whole globe. So that's particularly a challenge in moving forward. And then when we talk about actually issuing an alert or a warning to a citizen about some harmful weather, you really need human involvement for that. And I'll talk more about that inherent government responsibility of warning citizens in a future slide here. I do want to show you, though, just very well, here I forget, I have numbers on every slide, so they trip me up. So at the Weather Company, we, on a routine day, will issue 11 billion forecasts. If there's any significant weather going on, we'll go up to 26 billion here. We actually exceeded that over the weekend with the storms in the United States. And the point that I want to make, I don't expect anybody to get into the details of this slide, is we are really striving to provide forecast information on demand, because we find that's when decision makers need it, not really particularly on your model cycle or something like that. So that's one key point. Another point I want to make about this is we're very reliant on what governments do around the world, and we need to ensure that they're well funded as they move forward. And there's particular challenges. While I showed a lot of observations before, it's very uneven in the globe, and we have much more to do in that regard. So we're reliant on what the governments are doing moving forward, and that will be important for us. Engaging the decision maker, I want to talk about two ends of the spectrum. I want to talk about the individual, like this gentleman fishing here, and I also want to talk about businesses. So with respect to the individual, the prime concern here is to warn our citizens of hazardous weather so that they can take actions with respect to that. And the World Meteorological Organization, which is our body that promulgates policies and procedures, believes their policy is that this is an inherent government responsibility, and we think that is very true. And we all have a responsibility to make sure that our governments are strong and be able to issue these warnings and alerts for citizens here. There needs to be a single authoritative voice, and it's not a time to be confusing things across various domains. The other part of engaging decision makers, though, I'll just highlight the aviation industry, which is one that we work with quite a bit. We've had dramatic improvements over the past just 3 years with respect to forecasting turbulence. So the odds are, from the people in this room, I suspect that you fly fairly frequently to conferences like this and elsewhere. And it has gotten to be more a rare occurrence now that you need to deal with turbulence. And it's because of a symbiotic relationship with the aviation industry and companies like ours, where aircraft are instrumented with observations, taking observations today that flow back into our computer models. And then with that updated information, we can make a very good forecast on where there'll be turbulence, provide that information back to an airline, and they take corrective action. So I think it kind of highlights that you need to understand what's important to decision makers, what their business operations are for them to be able to move. And I think the discussions, particularly in one of the sessions yesterday afternoon, about engaging businesses in this global challenge we face is going to be very important, and it's going to really require us to understand business models and going forward. So I'll just click through this quickly. I just wanted to summarize again some numbers here. 2.2 billion forecast points around the country. We have 175 million cell phone users, and that number gets much bigger when we look at web and other things like that. We do this with actually a modest number of meteorologists at the Weather Company, 220. And our performance is really outstanding globally for that. So what's happening in the weather world, we've come really a very long way in this regard. But I think the other kind of considerations and all I want to talk about, I'll talk about partnerships more on the next slide, but I do want to mention technology. So the odds are everybody in this room is actually carrying a weather sensor, and it's your cell phone. So one of the things that we're working on now is being able to pull pressure data off of that, atmospheric pressure data that will help us in refining our forecast. But there's all sorts of technology out there, some of which we've heard about at this summit already. For example, the very small CubeSats that were talked about in yesterday morning's plenary would be another example of that. Policies, though, are something that we really need to pay attention to. I think the GEO effort is tremendously important in terms of promoting sharing of data, working with nations, but reaching out further to other organizations and eventually to businesses to do this. Because it's only by sharing this data that we're going to get the innovation that we need around it to develop the kind of tools that we need in going forward. So in my last slide, I just want to highlight what I consider as a big experiment that we're in the United States. And this has actually been instigated by the government sector, in this case NOAA, the National Oceanic and Atmospheric Administration, has realized that they have tremendous amounts of data that actually don't get out and get used as readily as they should be. Their policy is open access, but there's really a challenge in people being able to access the data, whether it's very historic data with respect to climate or fisheries data that comes in. So NOAA has made arrangements with multiple cloud providers. So in this case, we're talking about Amazon Web Services, Microsoft, Google, IBM, and another nonprofit organization. And the arrangement is that NOAA provides all of this data free of charge to the cloud, but at the same time, the cloud providers need to commit to providing that data without alteration directly to any end user that wants the data, so that there's not a markup or a fee there. It would be just the cost of access to that data. At the same time, the cloud providers are free to engage with any other parties, including companies like ours, to provide value-added services, to really harvest additional information out of that data that then could be used commercially for that. So I think it's a great example of a public-private partnership. I really say we're in the research and development phase of it now as we try to really unlock all of this data and get it in the cloud. But I think it will really be worth everybody kind of monitoring our experiences as we move forward here. So I'll wrap up with that and just remind you, if you look at the world and the world's problems through weather, it's really amazing in terms of, I think, both where we've come and where we're going. Thank you very much.
Thank you very much, Mayor. Mookie.
Thank you very much for the invitation to give this talk. And I'm going to talk in the next 10 minutes about what we call extreme citizen science and why we need it. I'll start with a very brief overview of citizen science from a specific historical perspective, where I'm highlighting human capability as an important aspect. Then I'll talk about where are the edges. And actually, in the last presentation, we already seen some of the edges of where citizen science practice is now. And then I'll talk about the technology and the processes that we need in order to do the extreme citizen science. So if we take the history of science and you kind of take the early period when science kind of agreed with itself what it's about, then we have the mid-19th century to the 20th century when science was professional. And now we're entering a period of opening science. But if we look not about science and not be just focusing on the science and look at society around it, you will see that in the very early science, with the society outside the scientists, mostly were illiterate even. Their level of education was extremely low. As we are talking about professional science period, in the 20th century, we started with people with very low level of education. We ended up with, in the Western countries and in developed countries, people getting into high school level. And now we are entering a period where a very large group of population have higher education. There are, at the moment, 250 million people in tertiary education, and that part of what fueling current citizen science. So here's what's going on in the very early period. You had citizen science for gentlemen or gentlewomen, and Mary Anning is a good example of citizen scientist of this period. She got 3 things wrong. She got class, she got religion, and she got her gender wrong, which meant that she couldn't be part of the Royal Geological Society. Only after her death they accepted her. Not only that, also the fossils that she discovered, and she had to sell them for living, were named after the men who bought them. So she's the exception who proved the rule of that period, and her history is interesting. The second period is the period where you could ask people to do things for you. So that's when the meteorological observation started. You couldn't expect people to do too much, but you could tell them, can you please every morning, 9 o'clock, please go out and measure the precipitation. And think about this volunteer, Rick Groker, I think we pronounce his name, from Australia, who recorded 250 millimeters a year in his place, you know, the number of nothing that he's collecting. And we actually know this fact. I can tell you this fact about 250 millimeters, probably because of him. So it's very valuable information. But as scientists go to create things that are automated and instrumented, they started to diminish the role of citizen scientists. But now we're entering a new period of citizen science. A lot of it is because this human potential that exists around us. And we can see it in many ways. So things that existed for a very long time, observation of butterflies and birds and other things, are now available through web form. And the fact that they are in web form means that the schema is much easier to digest. That's what enables it to be a much better data source for all sorts of issues. You can also have it in your phone. So you have the example of iSpot, an application that you take a picture of something that you don't know, in my case, a moth in the bedroom, which I wanted to know if it might eat the clothing. And within 45 minutes, I had the species in Latin, which indeed it had a problem with the clothing. So, you know. But in any case, you can do these things. You can also contribute your computer to citizen science through vast networks. This is an example from IBM Community Grid that allow you to join your computer, and this specific project, Computing for Clean Water, demonstrated a nanotube can be more efficient by 300% in providing clean water, and that's important. It's now available also on your phone, and you can download it right now if you want. And also there is the volunteer thinking. So you can log into Snapshot Serengeti, look at all the pictures that camera traps take, and learn about the animals that are living there, and also help scientists to do ecological observations. But the point about it is that it doesn't cover anything, everything. And if you remember the picture, try to remember the image that Mary just shown, and you would see that the middle of the Congo Basin, for example, is completely empty geographically. And the reason for that is that citizen science, in terms of the level of education of the people who participate in it, are the people with higher level of education. Also, at the bottom, you go through the scientific process, which starts from problem definition and end in some action. And in that case, you can see that we're still sticking citizen science too much in the area of data collection and a little bit in analysis, but less and less in other areas. So let's push it out. Let's kind of go to the extremes of citizen science and think about it in reaching anyone with any literacy to make them part of it. And that's where we come in. So the idea of extreme citizen science is to enable any community, regardless of literacy, to participate and design their own citizen science. So they can come up with a problem, collect the data, decide the protocol, and do all the work. Technology here is an enabler, but it must be contextualized within the specific tradition and practices of each community where it works. So here's one example. Sapelli is a software that we have developed, and you see there an image when it is used as a prototype for recording illegal poaching in the Congo Basin. And the way Sapelli is designed is not just a software. It starts actually with a process, and this is my co-director, Jerome Lewis, discussing with the community through a free and prior informed consent process what will be collected, who will collect it, who will use it, and how they're going to use it. That is followed by participatory design process, and this one is about agreement on logging and what community benefit will come to the community from it and which resources they would like to protect. Then moving from there to training and supporting through intermediary organizations that are staying around and helping community to do the process. It doesn't happen only in the Congo Basin. It also, another of our students, Carolina Comanduli, is doing a work with the Ashaninka people who are in the Brazil-Peru border. And over there, the community itself designed the forms, started collecting the data, and because they have GIS skills, they also starting to visualize it locally. And finally, there is another student of Jerome, Megan Lowes, who is currently working on a crowdfunding project where she wants to use the same system in the Nyanya Conservancy in Namibia. But, okay, so we have the data collection tool, but what are we going to do with that? We want to actually now implement how the data is going to be shared. And if you collected the data and you agreed on how the data was collected, and you have this agreement of who it's going to be shared with, you need the infrastructure that allow you to give this control and decide that the information about the elephants is not going to anyone but the conservation organization, whereas the information about some road can go to everyone and can help medical services. So to do that, we are currently developing another open source system called GeoKey, which is this infrastructure middleware for community mapping. And it's not just that we are locked into our system, sharing is everything. So being open, we are also linking to other systems. We are currently linking to EpiCollect, another data collection system, and thinking about how, and also to ArcGIS Online and other systems like that. So if we are now having that, and you see that we're starting to have this ability to use geographical technology to allow any community, regardless of literacy, to develop an own citizen science project, and we have the data collection tool, and we have the infrastructure, but how do we are going to give the information back to communities? And that's where our challenge is for the next period. So what we want to see is a world where there is a different data collection tool. There are us in the session after us. Louis Liebenberg is going to talk about a cyber tracker, and that's been there for a very long time. You got GeoKey and other systems, but what you want is tools that allow communities to see the data that they have collected. Another students in our group, Julia Altenbuchner, is done this work and started to work towards this idea of intelligent maps. With drones, you go over a village, you collect all the images, and then she done already one experiment where she tried to see how well people who never came across tablets or aerial photographs understand images, and the answer is very positive. There is really high success rate in understanding the information and pinpointing the information in the same place, and that's really positive. We need to do a huge amount of work to get from this into a fully functional GIS that can be used by anyone, but think about the opportunities. Think about what the world will be if GIS is not just locked for someone who need an MSc, but can be used by any farmers anywhere. So the summary is that there is, and we should be excited about the way that citizen science reemerge in the new form. It's open, it's allowing people to participate. They are producing environmental and knowledge production in many, many ways. We need to make the data collection universal, and that requires effort. That won't happen by itself. If we leave it by itself, we'll stay in the blue blob that I showed you. And not just us working on that, other groups are working on extending it in different dimensions. So need to give them their place. And also it's important to say that it's not just happening in the Congo Basin. If you go to our website, you'll see work in London about noise pollution monitoring by communities, or we just finished project with 10 communities in London doing community-based air quality measurement. But you need to support that. You need to go out and reach deprived community and marginalized group and women and other groups and make sure that they are included in that. And therefore, participatory design, intermediaries, collaboration, and sensitive technological development, not just, here's a technology, now use it. That's not the right way to do things. The right way is to have negotiation with communities on what to do. And you can find much more information on us on our website, and there is huge thank in all this work to all the communities and people that help us go to this point, and we've got the way forward with that. Thank you very much.
Good morning. All right, beautiful. Thank you very much to the hosts of this wonderful event. I really appreciate the invitation to speak. And I think it's perfect order, as you said, Barb, for my talk. I remember in the planning discussion, I talked a little bit about MapStory, and they said, yeah, but how does this relate to policymakers? Because many people here at this conference play in the policy realm and are trying to take data to decision. So I'm going to try to reflect on that a little bit through the context of what we are doing with MapStory. So I'm talking again about empowering policymakers with open data about our changing world. A lot of people will talk about geospatial data, and we're going to talk a lot about time today. Who here has heard about Wikipedia? Raise your hand. I would hope so, right? It's been going for 15 years in January. And has over 400 million edits a year, and it's the 4th most trafficked website on Earth. So I would hope you've heard about it. What does it let you do? It lets you organize and share what you know about the world in the form of encyclopedia articles. It's great. It's wonderful. It's changed my life. It's made life a lot easier for everybody on Earth. We looked at that and we said, that's really interesting. What if we, instead of following the encyclopedia metaphor, creating the free encyclopedia that everyone can edit and use, what if we created a free atlas of change that everyone can edit? Everyone on Earth can tell their stories about how the world has changed over time through geospatial data, more specifically spatial temporal data. Imagine, in this case, imagine your city. From the very first building that was ever built, and being able to convey all change over time, in this case since 1862 with Ames, Iowa. This wasn't done by a GIS department or a government. This was literally done by a college dropout who lived in his dad's basement. He just thought it'd be a cool project to do. And he did it in 80 hours of his own personal time, and afterwards said, darn, had I known then what I know now, I could have done this in 5 hours. I'll call it MapStory Local, and we'll just start doing the entire world. So the challenge to you, right, 15 years ago when Wikipedia existed, none of you were contributing. Maybe one person out there was contributing an article. But now, every one of us, if we see an error, we can just log in and fix it. There's actually the opportunity to map every single city that's ever donned the face of the planet since the beginning of time. And once it's done once, right, it won't be perfect, but once it's done once, nobody else ever has to do it again because it's out there in the global data commons. What about this? We look at our megacities. New York City is one of those megacities, but it started as Fort Amsterdam, right? In whenever it was, 1620s. And these are all of the boundaries and annexations that ever occurred between all the villages and all the townships and all the towns that ultimately led to New York City. First we had the Dutch, and then we had the British, and on and on and on. This could be done for every single town. Indeed, one person now has all the data for America's 100 largest cities, and he's just looking for people to collaborate with to slowly put it in there. It could be done for your city. Why do you care? Well, in his case, he was a genealogist at heart. When you get your great-great-grandmother's birth certificate, it has a city and county on it that most likely doesn't exist anymore. So where do you find her records? So he did it for that reason. But these are actual governing jurisdictions. This helps us understand so many things about how our world has changed. There's many reasons to put this data together. I'll just skip forward. This is public data, right? This is the US Census. There's very few things in the US Constitution that are required. One of them is to conduct a decennial census. Every 10 years, we have to map our population so that we can reapportion representative democracy. But here it's not just a census, right? This gives us a story of westward expansion, of political evolution, of urbanization, all through one public data set. But before it was put into MapStory, you had to know where to get the data set. You had to pay $50 for the CD. You had to get it. You had to load up GIS. You had to know GIS. You had to take time to load that data up. And now any third grader can press play and understand the history of all those things through the lens of a census. Sorry, go to the next one. This is the Scramble for Africa. There's actually a Wikipedia article called The Scramble for Africa, and there's no map. I can't press play and understand the Ottoman Empire in pink. And as the European colonial powers came in with the Belgians in the Congo and the Brits and the French, I can't actually understand that scramble for Africa. This is annual change of borders. We like to think our political borders don't change that often. This is annual change. And I could just play this. I mean, what are we sitting in? 1907. Get to 1957 when the United Nations, everyone agreed to decolonialize Africa. Then you can see the modern political evolution here, but we simply don't have enough time today. And this is scientific data. This is just one data set around drought that was sitting in an unstructured format. Well, I guess it's a structured format, kind of opaque format that a citizen could not look at. And a college student just dragged it and dropped it in the MapStory. And this is drought by week for 12 years, right? And that's just one data set that NOAA puts together. There's so many more that are out there. And this is all data that's kind of out there. It may not be in digital form, but why isn't it organized in space and time so we can literally understand everything that's ever happened on Earth through a spatial and temporal lens? And imagery. These are historical images of Evanston, Illinois, when they actually built out into the water. And these images were actually sitting on the wall, printed artwork in a sense. But no one could understand change over time. So you could imagine having all the images for everything you do. So to draw the metaphor, Wikipedia was built using a MediaWiki, a piece of open source software, by an open source software community. All we did with MapStory was we loaded up a thing called a GeoNode that's maintained by the OpenGeo community. We think of ourselves as a companion to Wikipedia. It's simply different in that you get to organize and share what you know about the world spatially and temporally instead of encyclopedically. And importantly, we're not a company, we're a community. It's a nonprofit. Every one of you can just start loading data about how you understand the world and telling stories about it. And this is a very long paragraph that you can read in your own time. So I wanted to answer some questions really quickly before I got off stage about why should policymakers care? It's cool, something fun to do with your kids. You can tell your community's history. It's a new way to organize what you know about the world, but why should policymakers care? So first of all, the only constant is change. Any policymaker that thinks, everything's going to be the same tomorrow as it was today, and things are the way they are today because weren't they that way yesterday, are wrong. They're fundamentally wrong. And if you can't understand the history of kind of how we got here, then you certainly won't be able to see forward. Second, everything on Earth has happened in space and time. It's kind of a weird, reductive kind of thing to say, but literally everything on Earth has happened in geographic space over time. And if we're not mapping it that way and organizing that way, what are we doing? We're denying ourselves the ability to actually understand how these things have changed and our ability to make policy with them. Governments around the world are increasingly discovering the value of open data. I think we've heard that many times over the past 2 days. But governments don't have a monopoly on data anymore. It used to be, you had to have a big government agency. I think we had a presentation today from the Weather Channel, right, on there's derivative data being made. There's all sorts of data being generated way outside of government domain. And no single data set solves a policy problem. Just because I have a data set doesn't mean it answers a policy problem. Oftentimes those policy problems are complex and require us to think critically about the variety of data sets that we're going to juxtapose with each other in order to tease out the actual things that answer our policy problems. Spatiotemporal data collected by governments, international organizations, NGOs, companies, and citizens all have value to the policymaking process. To think I can only make policy with government data is, I think we'd all agree these days, somewhat wrong-headed. And unfortunately, historically, there's been no place for openly licensed data, spatiotemporal data, to commingle. Where would I take government data and NGO data and citizen data and have it all commingle in space and time? There's really been no place for that openly licensed data to go and make it discoverable and accessible. And it's more than just data. I've talked a lot about data, but policymakers also need the ability to tell stories. You can have vast amounts of data, and one of the big dilemmas of the big data revolution is there's so many insights in one big data set. What are you going to tease out, and what stories are you going to tell? And they not only need to tell data-driven stories, but tell stories that are driven by spatiotemporal data. And it's not just governments, it's citizens too, right? We actually need the feedback of our citizens. We need them to provide insights because governments have finite resources. Governments can only invest in understanding so much, and at a certain point, we actually need citizens to be able to roll up their sleeves, collect the data, their observations, share them with the world, and give their narrative, give voice to themselves. And in many ways, this is empowerment. So to achieve this, you need an open platform. You need an open platform that's not owned by anyone, and one that provides everybody with global access and global reach. And that's what we've tried to do with MapStory. So, MapStory in many ways is an open educational resource for elementary school kids. It's something that parents and teachers can work with to help their children understand the world. But it just as easily bridges into the world of policymaking because the kinds of data that citizens put together often ends up being key to public decisions around critical things for our societies. So I'm going to end with some final points here. Policymakers and every information community, I like to call them passionate information communities, are always struggling with our rich past, our complex present, and our uncertain future. We're at a new and powerful place with regard to how policymakers and citizens can understand change because of technologies like this. And we've had a really long journey. We've invested in all this mapping stuff for, well, we can show maps from 10,000 years ago, but certainly over the past hundreds of years, we've invested heavily in trying to understand these things spatially and temporally. It's not just, I think one of the things I find interesting is it's not just the capabilities out there for governments and citizens, but it's this sort of stuff, when we show these videos, when we just press play on MapStory, kids are fascinated. It's something that empowers the next generation to really think critically about their world, and they find inspiration in it, which I find interesting. So storytelling, it's not just data storytelling, it's something that humans have always done, and it's something we do together. It's not just about data, it really is about trying to convey to each other what's important inside this data. And this is really about empowerment. It's empowering people to tell their stories and tell their stories to each other, tell their stories to their governments, and telling their stories to a global community that in a way enables us more collectively to deal with these complex challenges. We're a community, not a company. You could sign up today and be part of that community. You could go back to your home and map your town. You could load up environmental data as a citizen scientist. It's something all of you are welcome to be a part of, and we'd love to have you there. In the end, there's an opportunity here. Just the way Wikipedia 15 years ago opened up and said, why don't we just have an encyclopedia about everything? All of you are welcome to add your insights into this encyclopedia and continuously edit it over time as the world changes. We actually have an opportunity to load up everything that's ever happened on Earth. Going back, well, right now we only go back 300 million years. I understand our platform should really go back 4.5 billion years, but we have some engineering challenges we're trying to overcome. So you can have your plate tectonics data, which is already loaded up, that shows how the world has changed in terms of our geology. And you can actually load everything up down to the minute up till now. So isn't that a neat endeavor? And can we imagine where we'd be 15 years from now, the way Wikipedia is at 15 years? Properly done, this will enable a new generation, not just of citizens, but of policymaking. And I personally find that very exciting. So with that, I think I'm done. All right. Thank you very much.
Good morning. I am really excited to be here. I want to make sure that you know that I consider this both a pleasure and a privilege to be here, because you're doing something now that's very important. As everybody sort of has alluded to within their presentation, you're actually sharing your time with us. And time is one truly irreplaceable commodity we have at our disposal. But while our time is limited, it has infinite possibilities. And what has been happening on the stage this morning are people are talking about some of the possibilities of what we can do with our time. And so I want to thank you for sharing with me your time. Now today, in consideration of Space Week, I'm going to talk about space a little bit. But I really want to talk about this all in the context of what we do in the future. But I have to start off a little bit with the past and the idea that I actually grew up during this time of really radical innovations where the world seemed to be almost limitless. And so that's what actually had a big bearing on what I did. And in fact, when you looked at what was going on, we were fundamentally talking about how do we expand human presence. But it wasn't just space. When I was growing up, there was a civil rights movement, which actually led to lots of different changes in the world. I remember there was a whole revolution around dance and about a cultural revolution. How do we think about the world? How do we present ourselves in our stories? There were fantasies like Star Trek, right, that said we really made it through our nuclear era, we're going to be able to be something bigger and better. But always during that, for me, there was space exploration. It was very much a part of who I was. But I thought about greater possibilities. And so where it took me over the years was actually into space. So let me share with you just for a second some of my ideas and things that happened to me in space. So this is proving I was there. You got to do that, right? So I flew aboard the space shuttle in 1992 on Space Lab J, and it was a mission done with the Japanese Space Agency. And we did lots of different things, from working on semiconductor materials to looking at human adaptation to space. And I was back in this laboratory, and most of the time I spent in the back of a laboratory about the size of a school bus. But every now and then I would have the opportunity to look out the window. And when I would look out the window, I would see this incredible image. Here it was, the Earth, it almost iridesced from within. And there was this thin, shimmering layer of light. That's our atmosphere that supports our life form. And I had a revelation. You know how people are always saying, save the Earth? Even back then, they said, save the Earth. My revelation was, the Earth will be here. It's actually a confirmation of something I always believed. The Earth will be here. Right? This beautiful planet that warms us and cools us, that envelops us with all we need. When I looked at it, I was just struck by its sheer beauty, the beauty of the stars and the moon, and the Earth will be here. The issue is whether we will be here. Because you see, we can actually do things in such a way and treat this planet in such a way that it doesn't support our life form. So we need to get our ideas straight, and especially as we're starting to talk about data and things, this is really important. This whole idea about what do we do. Frantz Fanon, who was a Martinican psychiatrist in the 1950s and 60s, said, each generation out of relative obscurity must discover its mission, fulfill it, or betray it. And here's what I think our mission is really about, our generation's mission. We're going to have to learn to see ourselves and our future as inextricably intertwined with the health and the well-being, not just of ourselves and humans, but of this planet. From its ecosystems that we identify with to the smallest of microbes and the microbiomes, all the way to the mineral resources. Our future is included in that. And even though I'm going to really talk about, people want to say going into space, and the work that I do now is around a project called 100-Year Starship, which is about expanding human presence further. Let's be clear, most of us are not going to get off this planet. So what we do here is really important. So what I decided to do today was really talk about not the incremental changes, but how do we get to the extraordinary, and how the extraordinary actually changes who we are. Everybody here talked about things that are based on the extraordinary, that was based on extraordinary ideas and concepts that worked in the past. Map story, right? It's building on an incredible IT database, right? When we talk about weather, it would not happen without supercomputers and all the modeling that had to be done. It was the extraordinary that allows us to make these changes and these challenges today. So that's what I want to talk about a little bit, is to push for the extraordinary in terms of data and other things. But first, let's just talk about data a little bit. There is lots of data in the world, right? But there's some things we need to know. With all this data we're collecting, remember, just because you have data doesn't mean you really have information. And just because you really have information doesn't really mean that you have knowledge. We need to be clear on these things when we're pushing for data, when we're pushing for things. And the most important part is, just because we have knowledge does not mean we're going to be wise with it. All of those things come from how we use these pieces. And so a couple of other wicked truths about data as I go through and talk about this. It comes from medical school. In medical school, we used to talk about these different tests called specificity and sensitivity. And they would say that a test can be specific, right? That means that it will identify specifically a type of disease or problem. But there's also an idea of sensitivity. How frequently will it always pick up a certain disease? They're not the same thing. Specificity and sensitivity are not the same thing. And so if you have tests, if you're collecting data that may be specific and it may be sensitive, you may come up with different information. That's a wicked truth about data that we have to think about as we look at what do we do with data and information. And the other piece is we value what we act upon. We value and act upon what we measure. Let's do that again. We value and act upon what we measure. So we have to be very careful to understand, just because a measurement isn't there, it doesn't mean something doesn't exist, because sometimes we get fooled into actions because of other things. But compelling data can actually produce extraordinary results, right? What makes data compelling? What makes data compelling is that it causes us to pay attention. It provides us with opportunities. It provides us with being able to predict and prevent things and get rid of risk, but it also provides us with opportunities to do better and to do things differently. So when we look at data, what makes it compelling? It provides new perspectives from which to address known conundrums. So being able to see tornadoes embedded in storms, that's different types of data. It provides new perspectives as we look at how we're using land and the impact of us upon land. Data is interactive, right? So as we get information, people give it back to us, we feed it back to them. So the data really needs to be interactive. Those are the things that we look at. Data should be actionable. That's what compels it. So you get something that you can actually use and make a difference. And sometimes it's things like farming data and broadcast. Another area that requires us to do extraordinary things is looking at landscape epidemiology. How can we use remote sensing to look back at the Earth and understand its impact upon health, even upon vector-borne diseases? But it can be actionable. That's what makes it compelling. It connects us across time and to understand a universe greater than ourselves. So when we look at this, many of you probably already know what this is, but if you look at this, this is an image of water, right? This is the image that started to convince people to say that, yes, Mars still has liquid water. This convinces us of a picture of Mars that connects us with ourselves and with the universe further along. People ask for the extraordinary. Why go to Mars? I like to reckon it like being a doctor. You've only had one patient your entire career. You may not be the best doctor. You're not the doctor I want. I'd much rather have that physician who's seen many patients, and that's what planetology does for us. We start to understand a greater amount about the planet Earth. So data that's compelling doesn't have to be for us specifically, but it connects us across time and our understanding to a universe greater than ourselves. And so when you think about remote sensing, this image of the Hubble Space Telescope and data collection is one of the most incredible ones because, actually it's my favorite image from Hubble. It's the pillars of creation, which is where stars are born. But that kind of data is compelling. We want to see it. And then finally, data reaches its full potential when it's widely disseminated, right? When there are a diversity of people who are actually building that data and when it's accessible by many. I think those are the things that all of our panelists have been saying, but I'm going to put a caveat on this. The reason why this is so important is because it's not just about people collecting the data that you told them to collect. It's being able to respect and the data that people already know. When people talk about the space age, they talk about 1957, but that's not when the space age actually began. And so I'm going to do this caveat on scientists. Science didn't begin in the 1600s. It really began thousands of generations before me when one of my ancestors looked up at the stars and she saw the movement of these lights and she started to track them. That was the beginning of science and the observations of space exploration. So as we're able to appreciate and value those kinds of observations, then we have more power. The picture of map story. So when we look at that map of the United States and the population census, that's not really reality because the reality is that there were people there beforehand and they should be included in the story. The map of Africa with the scramble, right? It has to be superimposed upon the people who are already there in their civilizations and societies. That's the value of having a diversity of people involved in the data collection and the ideas. So those things are powerful. So it took me a long time to get to 100-year Starship. And I'm not going to spend a lot of time on it. But just suffice it to say that 100-year Starship is about tackling a really difficult problem in hopes that it's going to jumpstart and push radical leaps of innovation here and now. So going to another star, even though I had that picture of Star Trek up there where people zip, zip, zip around, it's really tough. The closest star to us is Alpha Centauri. It's 4.2 light years away, 25 trillion miles away. Takes light 4.2 years to get there. Light gets from the sun to the Earth in 8 minutes. It would take Voyager, which just left our solar system, that's been traveling at 35,000 miles per hour since 1977, it would take Voyager 70,000 years to get there. So we have to do something radical, right? Yes, it's energy and power so we can go faster, but a big part of that is sustainability. How do we create the kinds of renewable resources that we need? How do we understand human health and microbiomes? But the big part of that is not just the journey, even though I will tell you I would love to figure out how to get suspended animation, so I'll be around to go. But the reality is it's about how do we transform life here on Earth. It's an inclusive, audacious journey to transform life here on Earth, and it really pushes for those radical leaps in innovation. Why? Because all of the capabilities that are required for an interstellar journey are the very same ones that are required for us to survive as a species on this planet. That is the connection. That's the reason why I push for the extraordinary, to be able to move things forward. And in fact, we believe pursuing an extraordinary tomorrow creates that better world today. And so I would like to invite you to join us in different things. But I'm going to tell you just about one small project, and the whole idea of visualization and how do we do things. And that project is, if we can see, let's see what's going to happen here, one that involves kids, right? The first thing that I did when I left NASA was to start an international science camp called The Earth We Share, and this is in 1994, The Earth We Share, because at that point in time, NASA had made such a big impact on me about the importance of the environment, and having traveled around the world, it was important for me to understand that those pieces were there, and it's continued on. How do we work with students, which are going to be the issue? So we're looking at a project, we invite you to join in a global initiative that we're proposing, that we've started to work on, that addresses and connects students, right? Because the reality is that they have to be able to do lots of different things, and they have to see this world as something that's interconnected. So we have to start right now. We can't wait. We have to start right now. We want to connect students. We want to connect data, so getting them to take the data. And I'm not just talking about through their cell phone, but get out, get dirty, 3D, get in the mud, take some data, right? It's really important. And with space, so that we understand that right now on this planet, we're in space right now. Because the big thing is if people aren't connected with it, they'll never see it, they'll never feel it. And we want to connect developing and industrialized communities, and we want to provide accessible data that creates actionable and positive benefits for everyday people. And so those are the pieces we are. I'd love to spend more time talking with you about it, but we work with different organizations and we're pulling this piece together. But there's one organization I want to share with you, one of our team members, because we want to be able to give people compelling visualization of data. You can find us at www.100yss.org. But what I'd like to leave you with before I show you this compelling group that we're working with is the future never just happened, it was created. We're working on that future now, but we have to invite other people in. We can't just do it by ourselves. So yes, I like science. Yes, I've done all of those things. I'm, terribly excited about space exploration, but sometimes other people can tell the stories, and they can show us the data in different ways. And so one of our team members who is working with us on this EarthShare program to create this visualization, this data collection with students and others, is Kenji Williams, who is a musician, a violinist, a videographer. And I would like to share with my last minute and leave you with a video with Kenji actually sharing data in a very compelling, powerful way. And that's Kenji's music. He takes real data, puts it visually, puts it to music with a story.
The future never just happened, it was created. Thank you.
Okay, I sure hope that you feel like I do, that this was an absolutely outstanding panel. I have to say that, you know, not all the panelists even knew each other before this started. So if we want to just talk about synchronicity that was created here on stage, thank you, each and every one of you. Looking forward to that. I guess I'd have to say I can only feel, and I imagine you do, that I'm longing for more. Unfortunately, our time is out this morning. I can guarantee you that each and every one of these people are so committed, they're willing to stay after, so please take your time. If you've got individual questions to talk to them, do so. What an A-team. Thank you, everyone, very much. Please join me in taking on. Announcement.
Thank you, Barbara. Thank you very much indeed. Fascinating. You please feel free to leave the stage if you wish. Now, a few housekeeping announcements first. This forum takes things like citizen science and scientists very seriously. It wants to be the sort of glue that enables everybody to communicate and come together. And so there will be more on this later. Just to let you know that the Polar and Cold Regions Group are invited by GEO to a meeting in the boardroom at 12:30. 12:30. Barbara, do you know about this? Okay, that's fine. So Polar and Cold Regions Group invited by you, by GEO, to a meeting at the boardroom. That's okay. I'm sure it's taking place. Okay. And the third thing is that in order to create this common platform of knowledge, information, and so on, the organizers would like you to fill in a form about what you're doing and about your organization and to collate that data. There are these physical pieces of paper for you to fill in, and they are at the ENB tables in the breakout rooms. So please do that. And may I please leave you with one thought, picking up on the fantastic information that we heard. You know, when does information begin and end? I don't know if any of you have read a book called Fingerprints of the Gods. Hands up if you have. Fingerprints of the Gods. It's absolutely fascinating. I'll leave you to find out more about it. But basically, the author bases his theory on the idea that an ancient civilization, by the way, this is all not based on his feelings or a gut instinct, but on evidence that he has found. Things like maps, old maps that couldn't possibly have known things that we have discovered in the recent past through our technology. The point is, he believes an ancient civilization died out at the end of the last ice age. And with it, unfortunately, a lot of knowledge and information died out too, but he was able to gather sudden bits of evidence around it. He puts forward that mainstream interpretations of archaeological evidence are flawed or incomplete, and I find this fascinating. Think about this. Go and look up the book, Fingerprints of the Gods. There you go. Enjoy your coffee break, and I will see you later. Bye-bye.